Hello everyone, welcome to my channel. So in my channel I am going to upload a series of videos. So in these videos I am going to upload all previous year questions of state government examinations. Okay, state government examinations in the sense assistant executive engineer and assistant engineer exams, previous year questions. I will choose important questions for each topic. Okay, so for each topic I will upload a video. Okay, so first I am going to start with the strength of material subject. So for in strength of material subject there are 10 to 15 topics. So I will upload for each topic one video. Okay, so in each topic there may be around 200 to 250 previous year questions. Okay, so out of those 250 I will choose around 35 to 40 different questions. Okay, I will solve in a very conceptual way. Okay, so if you find these videos helpful for your preparation, so please subscribe to my channel. Okay, so first I am going to start with the topic transformation of stresses and strains. Okay, so remaining I will first complete the strength of materials every topic. Okay, so after that I will choose another subject. So first now I am going to start with transformation of stresses. Okay, so if you find these videos are helpful, please subscribe to my channel. Okay, now start solving these questions. So first, what he has mentioned in first question: if a member is subjected to a tensile force P having its normal cross-section area A, the resulting shear stress in an oblique plane inclined at an angle theta to its transverse plane will be. Now, before solving this question, I will mention you one thing. In case of transformation of stresses and strains, every question can be solved using one is transformation equations and another method is using Mohr circle. Okay, so for some kind of questions using transformation method it will be very easy, and for some kind of questions using Mohr circle you can solve those questions easily. Okay, I will solve using both the methods. Okay, whatever you find easy you can solve it. Now what he has mentioned in this question: in a member, if a member is subjected to tensile force P, that is, for suppose I have a member like this and here some tensile member P is acting, let's say tensile force in this direction. Now cross section area, this cross section area, normal cross section area, he is mentioned as A. Okay, so now he is asking to calculate on some plane which is an angle of theta, on this plane he is asking to calculate the shear stress, the value of shear stress. Let's take this as tau. Okay, so now you can solve this question using both transformation equations and Mohr circle. Okay, before solving this question, there are some special stress conditions like uniaxial stress condition, biaxial stress condition, triaxial stress condition, and pure tension. Pure shear case. Okay, and spherical stress condition. These are some special kind of some special stress conditions. Okay, if you take uniaxial stress condition, this is the example of uniaxial stress condition. Uniaxial stress condition in the sense, this will be the uniaxial stress condition. This force can be either tensile or compressive, it doesn't matter. Okay, this can be compressive stress or tensile stress, but only in one direction only the stress will be acting, and on that plane there won't be any shear stress. So this is uniaxial stress condition. And when it comes to biaxial stress condition, in case of biaxial stress condition, in two different directions, two perpendicular directions, you will be having normal stresses. Okay, so in biaxial stress condition you will have normal stresses on two perpendicular planes, and these two normal stresses can be compressive stresses or tensile stresses, it doesn't matter, but these two stresses should act on two perpendicular planes, and on these two perpendicular planes there shouldn't be any shear stresses. Okay, on these two perpendicular planes you shouldn't have any shear stress. Okay, so if you see here on these two perpendicular planes there is no shear stress is acting, so you can say this sigma 1 and sigma 2 will be these sigma 1 and sigma 2 will be principal stresses. Okay, so these two perpendicular planes will be principal planes. Why? On these planes only normal stresses are acting and shear stresses are zero. Okay, on any plane, if normal stress is acting and shear stress is 0, then that plane will be principal plane. And out of these two planes, which one is principal plane, which one is major principal plane, and which one is minor principal plane, you cannot decide now. Depending upon the value of sigma 1 and sigma 2, you can decide it. Okay, so out of the sigma 1 and sigma 2, whatever may be the maximum value in quantity wise, okay, sigma 1, sigma 2, whether it is compressive or tensile, it doesn't matter. In sigma 1, sigma 2, whichever we having higher magnitude, that will be the major principal stress. Okay, so now the third condition is triaxial stress condition. Triaxial stress condition is nothing but, if you take this as a three-dimensional case, this is sigma 1, on this perpendicular plane you will getting has sigma 2, on this plane you will having sigma 3. Okay, so sigma 1, sigma 2, sigma 3. So these are three principal planes. Okay, in case of triaxial stress condition, sigma 1, sigma 2, sigma 3 are principal planes acting on three perpendicular planes. Okay, there won't be any shear stress on these perpendicular planes. So from this case, you can observe sigma 1 and sigma 2 and sigma 3 are principal planes, principal stresses. Okay, these three are principal stresses. Now fourth one is pure shear case. In case of pure shear case, you will be having this kind of stress condition. Okay, all the planes shear stress will be equal, and on these two perpendicular planes there won't be any normal stress. Okay, there won't be any normal stress. This is called pure shear case. And fifth one is triaxial stress condition. Sorry, fifth one is spherical stress condition. Spherical stress condition. It is a special case of triaxial stress condition. What is the difference in case of triaxial stress condition and spherical stress condition? In this case, sigma 1 and sigma 2 and sigma 3 will be equal in magnitude and same nature. Okay, sigma 1, sigma 2, sigma 3 will be equal in magnitude in this case, in case of spherical stress condition. And these three have same nature and matter. That means the sigma 1, sigma 2, sigma 3 will be either compressive or tensile. Okay, same nature they will have. So this is spherical stress condition. Okay, these five are important stress conditions, special stress conditions. Now he is asking about uniaxial stress condition. Okay, out of these five, this is the first. This one will be the example of uniaxial stress condition. Now he is asking to calculate shear stress acting on that plane, which is making an angle of theta. Okay, so using if you solve using transformation equations, tau is equals to minus of sigma x minus sigma y by 2 into sine 2 theta plus tau xy cos 2 theta. Okay, so on these two perpendicular planes, tau xy is 0. Okay, so minus of sigma x is nothing but this is the sigma value. Sigma is equals to p by a. Here it is acting sigma is equals to p by a. So that is p by a minus 0 by 2 into sine 2 theta. So that will be equals to p by 2a into sine 2 theta. Okay, that is tau is equals to p by 2a into sine 2 theta. Okay, so this is using transformation equation. If you solve using Mohr circle, now see this is point 1, this is point 2. What is the coordinates of point 1? Point 1 coordinates are p by a, that is normal stress, and on that plane shear stress is 0. And second one, on second plane shear stress is 0, normal stress is 0. So 0 comma 0. So these two will be the normal. This one will be the 1 point, 2 point. If you draw a Mohr circle, this will be, you will get like this. And what will be the center of Mohr circle? Center of Mohr circle is equals to sigma x plus sigma y by 2 comma 0. So that is p by 2a comma 0. Okay, this will be the Mohr circle. And if you this direction will represent normal stress on plane 1. This direction will represent this direction, that is normal stress direction on plane 1. So now he is asking to calculate shear stress on this plane, which is making an angle theta. So let's take this value. Okay, he is asking to calculate. Let's take this is the sigma theta and tau theta. Okay, so you know, in case of stress condition, if the plane is making an angle of theta, in case of Mohr circle, it will make an angle of 2 theta. It it will make an angle of 2 theta. So now he is asking to calculate tau theta. So from here you can solve sin 2 theta is equals to, this is radius of Mohr circle, sin 2 theta is equals to tau theta divided by r. Okay, tau theta divided by r. Now you know radius of Mohr circle is equals to sigma 1 minus sigma 2 by 2, which is equals to p by 2a. Okay, so you will get tau theta is equals to p by 2a into sin 2 theta. Okay, so by using both transformation equations and by using Mohr circle, you can solve this question. Okay, so out of these four options, p by 2a into sin 2 theta, sorry, p by 2a into sin 2 theta, that is option B is correct option. Okay, so next one he is asking, if a prismatic member with the area of cross section A is subjected to a tensile load P, then the maximum shear stress and its inclination with the direction of load. So this is also example of uniaxial stress condition. So now he is asking, this is the stress condition, and here it is acting with an area of cross section A is subjected to tensile load P. Okay, and this area of cross section is A. Okay, now he is asking to calculate maximum shear stress and its inclination. So you know this is the uniaxial stress condition. So this will be major principal plane. This will be major principal plane, and perpendicular to the principal plane will also be another principal plane. As normal stress acting on that plane is 0, so this will be minor principal plane. Okay, and sigma major will be P by A, and sigma minor 0. Why 0? It is uniaxial stress condition system. So in that case, whatever may be the axial stress that is acting, that will be the major principal stress, and perpendicular to that plane will be minor principal plane. Okay, so sigma minor will be 0. Okay, now he is asking to calculate tau max. Tau max is equals to radius of Mohr circle, that is equals to sigma major minus sigma minor divided by 2. Okay, so sigma major minus sigma minor divided by 2, which is equals to P by A minus 0 divided by 2, which is equals to P by 2A. Okay, now you have the magnitude. Now you have to find out the plane, that is on which plane it is acting. You know the angle between principal plane and maximum shear stress plane will be 45 degrees, either 45 or 135, either 45 or 135. Okay, so now this is major principal plane, or you can say principal plane. Now it will make an angle of 45 degrees. Okay, out of 45 degrees or 135 degrees. So now you can get the answer, that is P by 2A magnitude, and which at an angle of pi by 4, on a plane which is making an angle of pi by 4 or 3 pi by 4. This is also a correct answer. Okay, so out of these the correct option will be option B. Okay, next question. In a prismatic bar carrying an axial force, the two planes on which normal and shear stresses are equal into the axial force at the angles. A prismatic bar, it is also a case of uniaxial stress condition, carrying an axial force, some force P is acting. The two planes on which normal and shear stresses are equal are inclined to axial force. Okay, on some plane the shear stress and normal stress acting on that plane are equal in magnitude. Okay, and some plane, some random plane, shear stresses and normal stresses are equal on that plane. Now he is asking to calculate on which plane these two will be equal. Okay, so in case of uniaxial stress condition, this will be the one of the principal plane. Okay, so if you calculate tau max is equals to radius of Mohr circle is equals to, let's take this is sigma. Okay, this is directly you take it as stress sigma, that is sigma minus 0 by 2, that is equals to sigma by 2. Okay, now let's calculate sigma average. Sigma average is nothing but the normal stress that is acting on the maximum shear stress plane. Okay, sigma average is the normal stress that is acting on maximum shear stress plane, which is equals to sigma x plus sigma y by 2 that you can take it as sigma major plus sigma minor divided by 2, that you will get sigma by 2. Okay. Now sigma average, in case of sigma average, I am taking sigma x plus sigma y by 2, which can also write it as sigma major plus sigma minor by 2. Why? In case of any stress system, the sum of the normal stresses acting on any two perpendicular planes will be constant. That is, for suppose let's take this is sigma x and sigma y. Let's take another two perpendicular planes. Okay, on this plane, let's assume sigma x dash and sigma y dash are acting, and in this case sigma x plus sigma y is equals to sigma x dash plus sigma y dash. Okay, on any two perpendicular planes, the summation of the normal stresses acting on those two planes, okay, will be constant. But here the condition is those two planes should be at perpendicular. Okay, those two planes should be perpendicular. So sigma x plus sigma y and sigma x dash plus sigma y dash will be constant. This can also write it as sigma major plus sigma minor. Why? Major principal stress and minor principal stresses are perpendicular to each other, so those two additions will be also constant. Okay, so now I am replacing sigma x plus sigma y with sigma major plus sigma minor by 2, which is sigma by 2. Now here if you see on maximum shear stress plane, tau max and sigma average both are equal. That is, on maximum shear stress plane, normal stress and shear stress are equal. Okay, that's what he is asking. On two planes, normal and shear stresses are equal. Find out those two planes. Okay, so maximum shear stress plane, normal stress and maximum shear stress are equal. So with respect to principal plane, what will be the angle to maximum shear stress plane? Pi by 4 or 3 pi by 4. Okay, so now the answer is option B. Okay, indirectly he is asking to calculate maximum shear stress planes. Okay, on maximum shear stress plane you are getting tau max and sigma average equal. Okay, next he is asking on a cantilever two strain gauges are placed. Some cantilever beam is mentioned. Okay, on this cantilever some P load is acting at some point. P load is acting. So here he has kept some strain gauges. Okay, now he is asking on a cantilever two strain gauges are placed at a distance of 5 centimeters. That he is mentioning between those two strain gauges 5 centimeters gap is given, and the stresses noted had a difference of 50 Newton per mm square. That is, stress difference is 50 Newton per centimeter square. Okay, when a concentrated load P is acting to the right of the strain gauges, if the section modulus he is mentioned Z is equals to 200 centimeter cube. Okay, the value of P, now he is asking to calculate value of the P, that is what is the magnitude of concentrated load. Now he is asking load, what is the load quantity. Now you know at these two sections he didn't mention at what point the stresses he is mentioning. Okay, let's take this one. If you see with respect to bending, the normal stresses on this section will vary with respect to y. As the distance from neutral axis is varying, the bending stresses will change like this. If you see this type of load is acting, okay, this will be the compressive load and this will be the tensile stress. Okay, as with respect to neutral axis, as the location is as the location is away from neutral axis, the bending stresses will be more. But he didn't mention anything about cross-sectional details, but he has mentioned section modulus. So now I am considering the maximum distance, the maximum point, or you can say the maximum bending stress that is producing at that section. Okay, so sigma is equals to m by z. Okay, so that is sigma max, you can say sigma max you will get. So at section 1, let's take this is section 1 and this is section 2. If I calculate the maximum stresses at section 1 and maximum stresses at the section 2, those two stresses difference is 50 Newton per centimeter square. Now he is asking to calculate P value. Okay, so let's take at point 1 bending moment, that is m1. I will take it as m1 is equals to, let's take this as the distance between point load and the section 2 is distance x. Now at section 1 bending moment is equals to p into x plus 5, p into x plus 5, and at point 2 bending moment is equals to p into x. Okay, so out of these two, which will have more bending stress? As m1 is more, that is at section 1 bending moment is more, the stress will also be more, that is m by z. Z is constant for throughout the length. Okay, section modulus is throughout the length constant. So at section 1 you will have maximum bending stress when compared to at section 2. Why? The bending moment at point 1 is more. So sigma max 2 is equals to m2 by z. This is m1 by z. So now take this as sigma 1, which is equals to m1 is nothing but p into x plus 5 divided by z, and sigma 2 I will take it as p into x divided by z. Now he is mentioning sigma 1 minus sigma 2 is equals to 50 centimeter square. Okay, now p into x plus 5 divided by z minus p into x divided by z is equals to 50 centimeter square. Okay, so p into x plus 5p minus px is equals to 50 into z. Now you can cancel it. 5p is equals to 50 into z. So p is equals to 10 into z. So z is nothing but 200 centimeter cube. So p will get 2000. Okay, 2000 Newton you will get. Okay, so this is option C is correct. Out of these, option C is correct. Okay, next question. If the center of the Mohr circle is at origin, the state of stress may be described as. Okay, so he is saying Mohr circle is like this. That is, the center of the circle coincides with Mohr origin. Okay, so let's take the let's start by analyzing the options. First one is he is saying spherical stress condition. As I have told you, in case of spherical stress condition, sigma, sigma, okay, sigma. So if you take two-dimensional stress condition, tau max, you can say sigma x plus sigma y by 2 comma 0, that is center of the Mohr circle. Sigma x plus sigma y by 2, which is minus sigma by 2 comma 0, which is equals to sigma comma 0. Okay, so the center of the Mohr circle is not at origin in case of spherical stress condition. Let's take shear stress condition. If you take shear stress condition, sorry, I am drawing two-dimensional. Let's use two-dimensional. So this is tau. At point 1 you will get 0 comma tau. At point 2 you will get 0 comma minus tau. Okay, so if you talk sigma x plus sigma y by 2 comma 0, what is the sigma x comma sigma? That is 0 by 2 comma 0. That is 0 comma 0. So in case of pure shear case, the center of the Mohr circle is origin. Okay, now let's analyze fully tensile. You can take uniaxial tension. Okay, in this case center will be sigma by 2 comma 0. In case of compression, in case of uniaxial compression, or you can say fully compressive, also you will get sigma by 2 comma 0 you will get. So out of these four options, in case of pure shear case, you are getting center of the Mohr circle at origin. Okay, you can directly analyze. Let's see if this is the Mohr circle he is mentioning. In case of Mohr circle, if you see at tau max, plane, you are getting 0 comma tau and 0 comma tau. That is, on these two perpendicular planes you are getting only tau, and there is no shear stress on maximum shear stress plane. Okay, there is no normal stress on maximum shear stress plane, which is pure shear case. Okay, so this is representing pure shear case. Okay, you can directly solve. I am just solving to analyze those options. Okay, so option B is correct. Next one is, if the Mohr circle for a state of stress is a tangential to the vertical axis at origin, the state of stress may be called. Now he is saying the Mohr circle is like this, that is, it is tangential to the vertical axis, that is y axis, or it can be like this also. Okay, it can be like this also. It is tangential to the y axis. Now he is asking that state of stress may be. If you see, let's take this one, first one. Here sigma comma 0 and 0 comma 0, which is nothing but the stress condition is like this, sigma, and here there is no normal stress. And if you take this one, this is minus sigma comma 0 and 0 comma 0, that is, he is mentioning it can be like this also. This is sigma compressive stress, and another principal plane the stress is 0, that is uniaxial stress condition. Okay, uniaxial stress condition. Okay, so in case of uniaxial stress condition, that is uniaxial tensile, it is uniaxial compression. Okay, this is uniaxial stress, uniaxial tensile stress condition, this is uniaxial compressive stress condition. So overall you can say it as uniaxial stress condition. Okay, so these two can be options, so you have to take uniaxial stress condition. Okay, here he is mentioned pure tension. This can be pure tension and this can be pure compression also, but these question perfectly suits this answer. Okay, this question represents both pure tension and pure compression, that which is uniaxial stress condition. Okay, so option D you should choose. Okay, next 51 question. In 51 question, a solid cube is subjected to identical normal forces on all faces. Okay, identical normal forces on all faces, which is the example of spherical stress condition. Okay, so as it is mentioned cube, so forces, that is force by area, you should take stress, and on this case force by area. So as area of cross section is same in all three perpendicular planes, you can take it as stresses also same, that is sigma and sigma. Okay, as he mentioned, it is a solid cube. Okay, forces equal in the sense area of cross section is also same for cube on all directions. Okay, so you can take it stresses on three perpendicular planes are same. Now he is asking to calculate volumetric stress to linear stress, volumetric strain to linear strain ratio. Okay, so you know volumetric strain formula. What is volumetric strain formula? Sigma x plus sigma y plus sigma z by E into 1 minus 2 mu. Here sigma x, sigma y, sigma z both are all of these three are equal in magnitude and nature also. So that is 3 sigma by E into 1 minus 2 mu. 3 sigma by E into 1 minus. Now let's calculate on any one linear strain. That can be sigma x, sigma y, sigma z. Okay, let's take sigma. Sorry, so xi. Let's consider it as xi. Xi is equals to sigma x by E. Let's take xi x minus mu into sigma y by E minus mu into sigma z by E. You can write it as sigma by E minus mu into 2 sigma by E, which you can write it as sigma by E into 1 minus 2 mu. So let's see, xi v by xi x, 3 sigma by E into 1 minus 2 mu divided by sigma by E into 1 minus 2 mu. So if you cancel, you will get 3. Okay, this 3 is answer, so option C is correct. Okay, now next question. He is asking, in a truss member, in order to avoid shear failure, the shear strength of the material should be at least. Okay, now in case of truss members, the member will be either tie member or strut member. In case of truss, either the member will be strut or tie bar. What is the meaning of strut member or tie bar? If you take a column, if you see, for suppose this is a column, in case of column, the column should not, if you take a strut bar will carry only axial compression. Okay, a strut is a member which carries only axial compression. Then what is the difference between column and strut? In case of column, if there is some eccentric loading like this, if there is some eccentric load is acting, that is some P, okay, it's not going through CG of the section. If some force P is acting with some eccentricity, then this column will carry some bending also. Okay, in column only compression force is not only compressive stress is not producing, it can produce bending also. Okay, but if you consider strut, a strut bar will carry only compressive force, only compressive force. If you take a tie bar, it will carry only axial tension, it will carry only axial tension, and a strut will carry only axial compression. This is important point. Okay, so a truss members, all the truss members will be either strut or tie bars. Okay, in case of truss, the members will carry only axial force. Okay, only carry axial force. So if that is axial compression, that will be a strut, and if that carry axial tension, that will be a tie bar. Okay, so in case of a truss member, every member will be either truss, strut or tie bar. Okay, so you should understand what difference between strut and column. Column, due to the eccentricity of loading, it can carry bending also. Okay, if you take this bar, if you take this column, if this is the axis, for suppose some load is acting at this point, okay, which is at a distance of E, then this column will carry this P load here, and you will get some bending with respect to this axis. You will get some bending with respect to this axis, which is P into E. Okay, so in column you will get bending stresses also. Okay, so but in case of stress member, only compressive stress you will produce. Okay, axial compression you will carry. So now he is asking to calculate, in case of a truss member, in order to avoid shear failure, the shear strength of the material should be, let's take this truss member is a tie bar. That means this is carrying axial tension. Okay, let's take this is as axial tension. Okay, so now this will be the case of uniaxial stress condition. So uniaxial, in case of uniaxial stress condition, tau max is equals to, tau max, what will be the tau max? Sigma major minus sigma minor divided by 2, which is sigma by 2. So in case of uniaxial stress condition, so the tau max, that is maximum shear stress, will be half of the tensile stress. So now he is asking to calculate the material will be safe. When it will be safe? It will be if tau max, that is sigma by 2, is if this value half of the tension. Okay, so that will be safe only when half the tension. Okay, this should be less than, that is tau permissible. Okay, that is tau permissible. Tau permissible of the member, if the tau permissible of the material should be greater than half of the stress in tension. Okay, so that option B will be correct for this question. Okay, so now the next question, 62 question. The maximum direct stress in a body subjected to pure shear stress 100 megapascal. So now he is giving a stress condition of like this. He is saying pure shear is carrying, and this is tau value is equals to 100 megapascal. Okay, 100 megapascal. Now he is asking to calculate the maximum direct stresses. Maximum direct stresses in the sense maximum normal stresses. Okay, so what is the maximum normal stress? That is nothing but major principal stress and minor principal stress. You should say major principal stress, maximum in the sense. Okay, so major principal stress you should calculate. So let's take, this is the stress condition. Let's take using Mohr circle, which is equals to 0, 100. Now second point is 0, this as per sign condition, this is minus 100, this will be plus 100. Why? It's giving clockwise, it's this one giving clockwise movement with respect to center. Okay, so you should take this as positive, and this is giving anti-clockwise with respect to center, so you should take it as minus 100. So now he is asking, let's draw a Mohr circle. It will be like this. This is point 1 and this is point 2. Let's draw Mohr circle like this. Okay, center will be 0, 0. Why? It is the case of pure shear. In case of pure shear, the center of the Mohr circle will coincide with origin of the coordinate system. So now you should know this is R and this is R, which is nothing but 100. This is 100. So this value, that is sigma, which is equals to 100, you will get. This is a sigma which is equals to minus 100. So these two are principal stresses. Okay, so these two are principal stresses. Now he's asking to calculate maximum direct stress, which is major principal stress and minus principal stress, which is nothing but plus or minus 100 megapascal. Plus or minus 100 in the sense, one is 100 megapascal tensile stress and another one is 100 megapascal compressive stress. So option B is correct answer. Okay, so he is changing the is saying maximum direct stress. He is not giving directly to calculate maximum principal stress. He is saying maximum direct stress. Direct stress in the sense normal stress. What is the maximum normal stress in the stress element? It will be major principal stress. Here major principal stress and minor principal stresses are equal in magnitude. So you have to consider both. Okay. Next, 30th question. What is he saying? 15. Sorry. When a body is subjected to equal and opposite forces. So when a body is subjected to equal and opposite forces, you can take this one, or you can say like this. But the next point is mentioning is acting tangentially. Acting tangentially in the sense along the surface, like this. Okay, along the surface the force is acting. Okay, so acting tangentially across the resisting section. Okay, across the resisting section. This is the resisting section. Okay, across resisting section in the sense this is the resisting section. You can take like this also. If you consider this one, you can say like this also. Okay, it doesn't mean it's acting tangentially with respect to the resisting section. So what is this? This is the example of shear stress. Okay, shear stress is nothing but which is acting tangentially with respect to the area. So what is the strain that produces shear strain? Okay, so that is shear stress and shear strain. So option D is correct option. Okay, next one. On a plane, resultant stress is inclined at an angle of 30 degrees to the plane. If the normal stress on the plane is 50 megapascal, the shear stress on the plane will be. Now you should know what he's saying. On a plane resultant stress, that is, let's take some plane like this. I have a plane like this. On this plane, let's take this as the normal stress, and on this plane, this is the shear stress. Okay, so the resultant stress is like this, which is, let's take sigma resultant. Okay, so he is mentioning on a plane resultant stress is inclined at an angle of 30 degrees with respect to the plane. To the plane in the sense, this is the plane. So shear stress is acting along the plane. So this will be the 30 degrees plane. Okay, to the plane or shear stress acting. Okay, so 30 degrees is this one. Now he has mentioned normal stress, which is equals to 50 megapascal. Now he is asking to calculate what is the shear stress on that plane. Okay, so let's take this one. That is, if this is 30 degrees, this will be 60 degrees. Okay, or you can solve using tan 30 is equals to sigma by tau. Tan 30 is equals to sigma by tau. So that is sigma is equals to tau is equals to sigma by tan 30 degrees. Okay, so here I am interested to tell you one more thing. Angle of obliquity. What is angle of obliquity? For suppose on some plane there is some normal stress sigma is acting and some shear stress is acting tau. If the resultant stress is sigma r, the angle made by the resultant stress with respect to the normal stress, angle made by the resultant stress with respect to normal stress is called angle of obliquity. Okay, angle of obliquity of any plane is nothing but the angle made by the resultant stress on that plane with respect to the normal stress. So here angle of obliquity is alpha, that is tan alpha is equals to tau by sigma. Okay, tan alpha is equals to tau by sigma. Now here the alpha is nothing but 90 minus 30 degrees, which is equals to 60 degrees. Okay, if he asks you what is the angle of obliquity, that is 60 degrees. Okay, so that is tan 60 degrees is equals to tau by sigma, which is equals to tau is equals to sigma into tan 60 degrees. You can solve like this or you can solve like this using, okay, by using simple equation, okay. Now what is the value? Sigma is given 50 and tan 60 degrees. You will get, by solving you will get 86.60, okay, 86.60 megapascal you will get, 86.60, okay. So out of these four there is no option, it is the result. Without solving I can say one thing. Here the resultant stress is near to shear stress, that is it is making an angle of 30 degrees with shear stress. It is making an angle of 60 degrees with normal stress. That means it is more inclined towards shear stress. It is more inclined towards shear stress. Then the tau should be more than 50 megapascal. Okay, should be more than 50 megapascal. So if I have this small logic, I can eliminate option A. Okay, so the answer should be, without solving anything, the answer should be more than sigma. Why? The sigma r is more inclined towards tau value, as tau will then only that means the tau value will be more than sigma. Okay, the tau value will be more than sigma. Okay, this is one point you can observe. Okay, you should understand what is angle of obliquity also. Okay, next question. If a member whose tensile strength is more than 2 times the shear strength is subjected to an axial load up to failure, the failure of the member will occur by. Okay, I have discussed this same type of question where a tie member, in case of truss, what will be the maximum shear stress he has mentioned. Okay, that type of question. Let's take this is the tensile stress, or you can say axial stress that is acting. What will be the tau max? Tau max is equals to sigma by 2. Okay, I'm directly writing it because you know that is, this is the major principal stress and this is minor principal stress. So sigma major is equals to sigma and sigma minor is equals to 0. Tau max is equals to radius of Mohr circle is equals to sigma major minus sigma minor divided by 2, which is equals to sigma minus 0 by 2, that is sigma by 2. Okay, I'm directly writing it. Okay, tau max is equals to sigma by 2. Let's now he is mentioning the tensile strength is more than 2 times of shear strength. Okay, so but the tau max is equals to sigma by 2. Okay, so let's discuss it by taking some values. Okay, so let's take the tensile strength, that is sigma permissible of this member as 70. Okay, sigma permissible as 70. So tau max will be equals to whatever may be the sigma you apply, it will be by 2. It will be by 2. But the shear strength is tau max is tau permissible the tau permissible will be less than or equals to 35. He has mentioned it, which is half of sigma permissible. Okay, the strength of the shear strength is less than half of tensile strength. So tau max is sigma by 2. You will get, let's say you apply 70, you apply sigma of 70, you will get a tau max is equals to 70 by 2, which is 35. So tau permissible should be less than or equals to 35. Okay, so in this case the material will fail due to shear. Material will fail due to shear. Why? The tau max that is occurring on the member is more than the permissible. Okay, so out of this maximum shear stress, it will fail due to maximum permissible stress. Okay, next question. The center of Mohr circle is coincident with origin of the coordinate axis when? So when will be the center of Mohr circle coincides with origin? So in case of pure shear case, it will coincide, but let's analyze this one. If I have a sigma x, sigma y, if I have a stress condition like this, sigma x, sigma y and some tau xy, okay, let's take a standard one. So in this case, center of the Mohr circle will be sigma x plus sigma y by 2 comma 0. Okay, now he is saying this is nothing but origin of the Mohr circle. So that is sigma x plus sigma y by 2 is equals to 0, which it means sigma x is equals to minus sigma y. Okay, so that means on any two perpendicular planes, the summation of the normal stresses should be 0. Okay, the summation of the normal stresses should be 0. So sigma x is equals to minus sigma y, this answer. So this can be like this also. This is nothing but pure shear case. Okay, this is nothing but pure shear case. On these two perpendicular planes, shear stresses are 0, summation of shear stress. So it is nothing but on this plane, if you take 45 degrees planes, on this plane you will get sigma, on this plane you will get minus sigma, and you can say compressive stress. Okay, this is nothing but the stress condition he has given is nothing but pure shear case. Okay, so the option is option B. Next one is for an element under effect of biaxial state of normal stress, the normal stress on a 45 degrees plane is equals to. Now he is saying biaxial stress condition. Okay, in case of biaxial stress condition in the sense, let's take this as a biaxial stress condition. That is sigma 1 is acting here and sigma 2 is acting here. Why? These are the principal stresses. In case of biaxial stress condition, there won't be any shear stress on these planes. Okay, so this sigma 1 and sigma 2 will be major principal stress and minor principal stress. I don't know which one is major and which one is minor, but I am just mentioning sigma 1 and sigma 2. Now he is asking to calculate normal stress on 45 degrees plane. So 45 degrees plane is nothing but maximum shear stress plane. So maximum shear stress plane, the normal stress on maximum shear stress plane is nothing but sigma average, which is equals to sigma x plus sigma y by 2. So here sigma x plus sigma y is nothing but sigma 1 plus sigma 2 by 2. Okay, sigma 1 plus sigma 2 by 2. That is nothing but the summation of the normal stresses by 2, which is nothing but half of the sum of normal stresses. That is option C correct. Half of the sum of normal stresses. Okay, so next question is the resultant stress on an inclined plane which is inclined at an angle of theta to the normal cross section of the body, which is subjected to a direct tensile stress sigma. So in case of uniaxial stress condition, he is mentioning, okay, that is I have a bar like this, and which is inclined, which is making an inclined the resultant stress. Okay, let's take this as a sigma. He is asking to calculate the resultant stress on an inclined plane. A resultant stress in the sense, let's take, I have a plane like this which is making an angle of theta. If you see this plane, on this plane there will be some normal stress, that is sigma theta. I am mentioning some tau value which is tau theta. He is asking to calculate resultant stress acting on that plane. So resultant stress is nothing but, as these two stresses are perpendicular to each other, that is sigma and tau, so you can write it as sigma theta whole square plus tau theta whole square. Okay, let's first calculate sigma theta and tau theta. Sigma theta is nothing but, using principal stresses, you can write it as sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy sin 2 theta. Now in this case tau xy is 0. Okay, so sigma x is nothing but sigma, so that is sigma by 2, y is 0, as on this plane there is no shear stress, that is sigma y is equals to 0 plus sigma by 2 into cos 2 theta, which is equals to sigma by 2 into 1 plus cos 2 theta. Now let's calculate tau, that is the shear stress acting on that plane, that is equals to minus of sigma x minus sigma y by 2 into sin 2 theta plus tau xy cos 2 theta. So tau xy is not 0, so that is sigma by 2 into sin 2 theta. Okay, this is tau theta. Now let's calculate the resultant, which is equals to sigma theta square plus tau theta square. You will get square root of sigma by 2 into 1 plus cos 2 theta whole square plus tau theta is nothing but sigma by 2 into sin 2 theta whole square. Let's take common sigma by 2 common, that is equals to square root of 1 plus cos 2 theta whole square.
1 square plus cos square 2 theta plus 2 into cos 2 theta plus sin square 2 theta. So 1 cos square theta plus sin square theta is nothing but 1, that is equals to sigma by 2 into 2 plus 2 into cos 2 theta. You can take it as you can take it common. Okay, so that is sigma by 2 into root 2 into square root of 1 plus cos 2 theta. Okay, so by solving it, that is you can sigma by root 2, if you can write it as root 2 common, sigma by root 2 into 1 plus cos 2 theta. So you know 1 plus cos 2 theta by 2 is equals to 1 plus cos 2 theta by 2 is equals to cos square theta. You know that 1 plus cos 2 theta by 2 is nothing but cos square theta. 1 plus cos 2 theta by 2 is nothing but cos square theta. So if you take sigma divided by 1 plus cos 2 theta by 2, which is equals to square root of cos square theta, which is sigma cos theta. So sigma cos theta is the answer, that is B, option B. Next, 83 question. When an element of a specimen of brittle material is subjected to shear stress is nothing but pure shear. If you apply pure shear on a brittle material, the crack propagation, if occurs, will be the inclined to an angle. Okay, crack propagation, how will be the crack propagation, he is asking. Let's take this is a brittle material. Okay, I am applying some shear stress like this, pure shear. Okay, so this will be the maximum shear stress planes. Okay, so when it comes to brittle material, the brittle material is strong in shear but weak in tension. Okay, the brittle material will be strong in shear but weak in tension. So in this shear case, whatever may be the shear stress, whatever may be the major principal stress plane, the crack will occur on that plane. Okay, whatever may be the maximum tensile stress plane, the crack will occur on that plane. Why? The brittle material will fail due to tension. Why? It is weak in tension. Okay, so if you see this stress condition, so sigma major will be, let's take this as tau, sigma major will be tau and sigma minor will be minus tau, that is compression, this is tension. Okay, so this the let's directly do it. This will be the major principal stress. Okay, which is an angle of 45 degrees to this one, which is an angle of 45 degrees this one. Okay, so this will be the major principal stress and this will be minor. Okay, so the plane which is carrying sigma major, that is tau major principal plane, or you can say maximum tensile stress. So this plane will carry this major principal stress, that is maximum tensile stress. So the crack will occur with respect to like this. Okay, which is making an angle of 45 degrees. How you can see it is 45? This one is 45 as this normal, and the plane the stress normal to the plane is making 45 degrees. So this will make an angle of 45 degrees. Okay, so the crack will propagate with like 45 degrees plane, on 45 degrees plane. Okay. So here I am mentioning one more time, in case of pure shear case, if the shear case is like this, okay, this will be the major principal stress, which is tau, if you take this as tau, and here you will get minor, you can't say minor principal stress, you will get the same tau value but is compressive nature. Okay, if you take this kind of stress condition, that is like this, okay, opposite to the before mentioned stress kind, here you will get tau value, that is tau, that is a major principal, you can say sigma 1, that is tau tensile. Here you will get compressive sigma 2, that is minus tau, which is nothing but compressive stress. Okay, so here whatever may be the stress condition you take, you will get 45 degrees on the plane which is making an angle of 45 degrees, you will get the crack. Okay, so why we are taking only maximum tensile stress plane? Because the brittle material will fail due to tension. If you take mild steel which is ductile in nature, it will fail due to shear. Okay, it will fail due to shear. Next, an element subjected to two equal and like stresses sigma, the two mutual perpendicular planes, the shape of the Mohr circle. Shape of the Mohr circle, that is, I have a stress condition like this, subjected to two equal and like stresses, that is sigma, and two mutually perpendicular planes. Okay, so if you are taking like this, he is asking the shape of the Mohr circle. So first, what is the center of the Mohr circle, that is sigma x plus sigma y by 2 comma 0, which is sigma plus sigma by 2 comma 0, which is nothing but sigma comma 0. This is center of the Mohr circle. Now let's calculate radius of the Mohr circle. Radius of the Mohr circle is nothing but tau max, which is equals to sigma major minus sigma minor divided by 2. Okay, so let's see, this is also an example of biaxial stress condition. So in case of biaxial stress condition, this is one of the principal stress and this is one of the principal stress. As on these two perpendicular planes there is no shear stress, these planes will be principal planes. Okay, if you take sigma major, which is sigma, and if you take sigma minor, which is sigma, so you will get 0. So the Mohr circle will have center, which is sigma comma 0, and radius of the Mohr circle is 0. So that is nothing but a point. That is nothing but a point. So option D is correct. The maximum shear stress will be equal to. Okay, so that is sigma max will be equals to, he is mentioning tau max. Sigma maximum shear stress will be equals to 1/2 of the algebraic difference of maximum and minimum normal stresses at that point, which is, what is he mentioning, that is tau max is equals to sigma major minus sigma minor by 2. That is what he is mentioning, right? So this is the formula we have. So he is mentioning that one only. So that is the difference of algebraic difference of maximum normal stress, that is major principal stress, and another one is minor principal stress, which is nothing but minimum normal stress. Okay, so the option statement 1 is correct. So maximum principal stress is nothing but, maximum shear stress will be equals to half of the algebraic difference of the maximum and minimum normal stresses, which is nothing but algebraic difference of the principal stresses. Okay, algebraic difference of principal stresses. So option A is correct. In case of pure shear at a point, in case of pure shear, so let's take this as a pure shear. In case of pure shear at a point, the sum of the normal stresses on two orthogonal planes is, at any element, the summation of the normal stresses acting on any two perpendicular planes will be constant. On any two perpendicular planes, the summation of the normal stresses will be constant. So let's take here, on this plane, what are the normal stresses? That is 0. So that is sigma x plus sigma y is 0. Okay, sigma x plus sigma y is 0. So on this element, on any two perpendicular planes, the summation should be 0. The summation should be 0. Why? On these two perpendicular planes, the summation is 0. So that means on any two perpendicular planes on this element, the summation of normal stresses should be 0. Let's take major principal stress and minor principal stress. If you take on this plane, sigma will act that is tau. On these planes, the sigma will be minus tau, which is compressive. So the summation will be tau minus tau, which is 0. Okay, so in case of pure shear condition, the sigma x plus sigma y will be 0. Then only the center of the Mohr circle will be coincide with 0, 0. Okay, then only the center of Mohr circle will coincide with origin. Okay, so sigma x plus sigma y by sigma y should be 0. Okay, so next, in Mohr circle, center of circle from y-axis is taken as, center of Mohr circle is nothing but this. Let's take this is Mohr circle. This, what is the center of this Mohr circle? Sigma x plus sigma y by 2. So he is asking to calculate what is the center of Mohr circle distance from y-axis. So which is nothing but x coordinate. Which is nothing but x coordinate. This is nothing but x coordinate, right? So which is nothing but sigma x plus sigma y by 2. Okay, so option C correct. So maximum shear stress in Mohr circle is equals to. So maximum shear stress is Mohr circle is nothing but radius of the Mohr circle. Okay, so maximum shear stress is nothing but radius of the Mohr circle. Okay, so you should have known it. Okay, next. On principal planes only dash stresses act. You know, on principal planes only normal stresses will act, shear stresses will be zero. Okay, on any principal plane shear stress will be zero and normal stresses will exist. Okay, here he has mentioned axial bending torsion. We are mentioning only normal stress. This normal stress can be due to axial loading or it can be due to bending. Okay, so you know, due to axial loading and bending you will get normal stresses, and due to torsion you will get shear stresses. But we are not bothered about whether that normal stress is due to axial loading or bending. We are just interested in whether it is normal stress or shear stress. Okay, so on principal planes we only have normal stress. Okay, we don't have any shear stress, so option D is correct. Next one is for which one of the following stress condition the diameter of the Mohr stress circle is zero. Okay, for which one of the following stress condition the diameter of Mohr circle is zero. So diameter of the Mohr circle is zero in the sense radius of the Mohr circle is zero. Okay, so as he mentioned, radius of Mohr circle is zero. So you know, radius of Mohr circle is nothing but tau max. Tau max or radius of Mohr circle is equals to, that is sigma major minus sigma minor by 2. Sigma major minus sigma minor by 2. Here he has given sigma 1, sigma 2 like this. So if you, out of these options, if you take which one of the following diameter of Mohr circle is 0. So if you take out of these 4 options you should take. Now if you see the options, you have sigma 1, sigma 2 and q. Okay, so what is trying to say, sigma 1 is nothing but sigma x, sigma 2 is nothing but sigma y, and q is tau xy. Okay, he is giving, he didn't give sigma 1, sigma 2 which are principal stresses. These are not principal stresses, these are stresses. Like, so if you see radius of the Mohr circle, radius of the Mohr circle is, in case of transformation equations, that is minus of sigma x minus sigma y by 2 sine 2 theta plus tau xy cos 2 theta. You can use this formula. You can use this formula if he has given principal stresses. But if you see the options, these are not principal stresses. He has given sigma 1, sigma 2, even though sigma 1, sigma 2, but those are not principal stresses. They are like sigma x, sigma y and tau xy. Okay, so now see, for to have radius of Mohr circle is 0, you should have tau max, radius of Mohr circle is equals to minus of sigma x minus sigma y by 2, and tau xy, these two values should be 0. So for that you should have tau xy 0 and sigma x minus sigma y 2 should be 0. So if you see sigma x minus sigma y is equals to 0, then sigma x should be equals to sigma y, and at the same time tau xy should be 0. Okay, so out of these options, if you see first one, even though sigma 1 and sigma x and sigma 2 are 0, but you have some shear stress. You have some shear stress. Okay, and the second case, sigma 1 and sigma 2 are opposite, so that's not correct. So out of this, fourth option is correct, which is sigma x is equals to 400. Sigma x is equals to, so out of these questions, option D, like sigma x is 400, sigma y is 400, and tau, that is q, that is tau xy is 0. Okay, sigma x and sigma y are opposite. So you will get, if you calculate using this calculator, if you calculate tau max, which is radius of Mohr circle, you will get sigma x minus sigma y by 2 whole square plus tau xy whole square, which is nothing but 0, 0. You will get 0 values. Okay, so radius of Mohr circle will be 0. So that is option C is correct. Here he has mentioned option D, but option C is correct. Okay. Sorry. Here I have mentioned radius of Mohr circle, this formula. This is not correct. Radius of Mohr circle should be tau max is equals to, radius of Mohr circle is equals to sigma x minus sigma y by 2 whole square plus tau xy whole square. So this value should be 0 and this value should be 0. So sigma x is equals to sigma y you should have, and tau xy should be 0. These two conditions should satisfy to get radius of Mohr circle 0. Okay, so this is wrong. This one is wrong. Okay, I will write again. I will solve this question again. Okay, let's see again. Now he has mentioned tau max or radius of Mohr circle should be 0. So radius of Mohr circle or tau max is nothing but sigma x minus sigma y by 2 whole square plus tau xy whole square. For radius of the Mohr circle to be 0, this value should be 0 and this value should be 0. So sigma x minus sigma y by 2 should be 0. So which is nothing but sigma x will be equals to sigma y and tau xy should be 0. So both these conditions should satisfy. Okay. So out of these options, if you see option C, they will satisfy these two conditions. Okay. So option C is correct. Next. In a component stress system, sigma x is given as S and sigma y is given as S by 4, the maximum shear stress for this condition. So sigma x is given S and sigma y is given S by 4. Okay, so it means it didn't mention whether it have any shear stress or not. So we should take it like this, that is S and S by 4. Okay, so these two will be principal stresses. Now he is asking to calculate absolute maximum shear stress of this condition. So you know, if you take tau max, you have two type of things, that is absolute maximum and you should take in plane shear stress, in plane maximum shear stress, in plane and absolute. If you take absolute, which is equals to maximum of sigma 1 by 2, as sigma 3 is 0 in this case, I am taking sigma 3 as 0 directly. So sigma 2 by 2 and sigma 1 minus sigma 2 by 2. Okay, out of these three, whatever may be the maximum value, you should consider it as absolute maximum shear stress. If you take in plane maximum shear stress, you will get sigma 1 minus sigma 2 by 2. Okay, so if you take in plane maximum shear stress, let's take in plane, that is S minus S by 4 divided by 2, you will get 3S by 8. You will get 3S by 8. But we don't have this option. If you take this one, maximum of sigma 1 by 2, which is nothing but S by 2, sigma 2 by 2, which is S by 8, third one is 3S by 8. So out of these three, this value is maximum. Out of these three, S by 2 is the maximum value. So out of these options, option C is correct, which is S by 2. Okay, so next question. Okay, if he didn't mention anything, you should take absolute maximum shear stress. Okay, next. Principal planes will be free of. I have mentioned earlier, principal planes will have only normal stress. Okay, they don't have any shear stress. Okay, so shear stress 0. It should be free of shear stress. Next. If a body carries two unlike principal stresses, okay, if a body carries two unlike principal stresses, the maximum shear stress will be given by. Okay, let's take this by considering some example. Like, let's take, I have some 40. This is one principal stress, and I have another principal stress which is opposite in nature, that is 20. Okay, so sigma major will be 40 and sigma minor will be minus 20. Okay, minus 20. Now if he asks to calculate tau max, which will be equals to, let's take absolute maximum shear stress. Okay, absolute maximum shear stress, whatever it may be, sigma major minus sigma minor divided by 2. So here 40 minus 20 by 2, which will be 60 by 2, that is 30. Okay, so now here, due to negative sign, minus of minus will become positive, that is 40 by 20 you got, 40 by 20 into 2. So now he is saying, that is if a body carries two unlike principal stresses, that is one is compressive and one is tensile, the maximum shear stress is nothing but half of the sum of the principal stresses. Okay, magnitude wise is saying you don't consider the sign, that is negative and positive. The value, the maximum shear stress will be equals to summation of those magnitude. Okay, summation of those magnitude, those principal stresses. So which is option D correct. Option D correct. Next, for a two-dimensional stress system, the coordinates of the center of Mohr circle. Center of Mohr circle is nothing but sigma x plus sigma y by 2, that is x coordinate, and 0 and y coordinate. So the center of the Mohr circle will always lie on, okay, so I am mentioning C is sigma x plus sigma y by 2 comma 0, that is center of the Mohr circle, which means as we are getting 0, y coordinate as 0, so the center of the Mohr circle will always lie on x-axis. You should remember it. Okay, you should understand. The center of Mohr circle will always lie on x-axis. Okay, whatever it may be, it can be here or here like this, wherever it can be. The center of the Mohr circle should always lie with x-axis. Okay, next. If a small concrete cube is submerged deep inside still water in such a way that the pressure exerted on all faces of the cube is P, then the maximum shear stress developed in that. So it is an example of hydrostatic stress condition. So that is, let's take, this is the cube. On this cube, all the principal stresses, that is on all directions, the principal stresses are equal, that is, which is P value. Okay, stresses in such that the pressure exerted on all faces are equal, which is P. So this is the example of hydrostatic stress condition. This is the example of hydrostatic stress condition. Now he is asking to calculate tau max. He is asking to calculate tau max. You know, absolute tau max is equals to maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, that is sigma 3 minus sigma 1 by 2. Okay, so now here we have sigma 1, sigma 2, sigma 3, which is P. Okay, these three stresses are equal in magnitude and same in nature. So here you will get 0. Why? Sigma 1, sigma 2 all are equal. So absolute maximum shear stress is 0 in case of hydrostatic stress condition. Okay, so this is option A correct. So this is important kind of question. In case of a hydrostatic stress condition, you will have maximum shear stress 0. That means on any plane, the shear stress will be 0. On any plane, in case of hydrostatic stress condition, on any plane, the shear stress is 0. Next one is, a shaft of sectional area A is subjected to an axial force P. The normal stress on a plane inclined at theta. That is, I have a body like this and it is subjected to P force. Let's take the stress which is P by A, which is sigma. So normal stress on a plane inclined at an angle of theta, he is mentioning. Inclined at an angle of theta. So he is asking to calculate on that plane, normal stress on that plane. So let's take this as sigma theta. Let's take sigma theta is equals to sigma x plus sigma y by 2, using transformation formula if you use, minus of sigma x minus sigma y by 2 into cos 2 theta plus tau xy sin 2 theta. Now this is sigma x, which is nothing but sigma x. Okay, sigma x is equals to, you got this one, sigma x plus sigma by 2 is nothing but sigma by 2 plus sigma by 2 into cos 2 theta. Now tau xy is nothing but 0. Okay, on this kind of stress condition, sigma x is sigma y is 0 and tau xy is nothing but 0. Okay, out of this stress condition we get these values. Okay, so if you solve sigma by 2 into 1 plus cos 2 theta, this is the answer. But sigma into 1 plus cos 2 theta by 2, okay, you can write it as 1 plus cos 2 theta by 2 as cos square theta. Cos square theta. So answer is sigma cos square theta. Okay, so sigma is nothing but P by A. So P by A into cos square theta you can write it as. Okay, so option B is correct. Ikkada now here the key point is 1 plus cos 2 theta by 2 is cos square theta. If you don't know this, you won't get this answer, even though you have all the concept. 1 plus cos 2 theta by 2 is cos square theta. If you don't know this, you won't get the answer. Okay. Next, if normal stresses of same nature px and py, okay, normal stresses px and py are acting, and these two are equal nature, that is either both are tensile or both are compressive, and some shear stress q is acting. Okay, some q is acting, then the major and minor principal stresses he is asking to calculate. Now sigma x is nothing but px, and sigma y is equals to py, and tau xy is equals to q. Now he has mentioned relationship between sigma x, px, py and q, which is equals to q square is equals to px py into 1 by 2, which is nothing but q square is equals to px into py. Px into py is mentioned. Now he is asking to calculate major minor principal stress. You know, major principal stress or minor is equals to formula using transformation equation. You can get that is equals to sigma x plus sigma by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. Okay, this is the formula transformation equation we use to calculate major and minor principal stress. So sigma x is nothing but px plus py by 2 plus or minus square root of px minus py by 2 whole square. Now tau xy square is nothing but q square. So you can write q square as px into py. Okay, so that is px plus py by 2 plus or minus square root of px minus py by whole square plus 4px py by 4. So a minus b whole square plus 4ab is nothing but a plus b whole square. Okay, so that is px plus py by 2 plus or minus square root of px plus py whole square by 4. So you can get px plus py by 2 plus or minus px plus py by 2. Okay, so if you take plus value, you will get major principal stress, and if you take minus value, you will get minor principal stress. So sigma major will be equals to px plus py. Okay, so sigma minor will be equals to, if you take minus value, both will cancel, then you will get 0. So the option D is correct. Okay, so these are the important questions I found out. So if you like this video, please like, if you found this video really helpful, please like this video and subscribe to my channel. I'm going to upload all the topics, important previous year questions I'm going to upload. So if you have any suggestion, or if you find any problem, or you can say if you have any suggestion, please comment below whether you like this video or not. So I have a Telegram group where you can join, so that if you have any doubts while preparing for any state government examination or GATE examination, I will try to answer those questions if you post in my group. Okay, so please join my Telegram channel also. Okay, thank you.